am K. Prakash, working at Aston Professor in the Department of Mechanical Engineering, SNS College of Technology. Today we are going to discuss about the Joule Thomson coefficient or Joule Thomson effect. So before going to the topic, let us see what is Joule Thomson effect and what is it related to. So this Joule Thomson effect is related to some cooling. So here what happens in this Joule Thomson effect? So here in the Joule Thomson effect, the velocity and the pressures are changed, and then we are getting a cooling effect by keeping the entropy as a constant value. So this effect of getting cooling is called as Joule Thomson effect. Okay, how this is possible? Okay, let us see how this is possible in this lecture video. So here let us see what are the setup available for this experiment. So here there is a passage. So here we are having thermometers. So one is kept as a constant area, and here there is a porous plug is there. Okay. So now what happens is initially this valve is closed, and here the parameters can be measured, the pressure, velocity and temperature. On the other side also the parameters can be measured. So now normally what happens is the gas is taken, it has connection with the water trap. So first initially it is allowed to have its thermal equilibrium. It is allowed for some time to wait for thermal equilibrium. So after getting the thermal equilibrium, what happens is slowly this valve is open. So when the valve is open, what happens is, so the gases passes through this porous plugs and comes to the other side of the passage. This setup. So here, so what are about the parameters? What happens with the parameters here? So here the constant area side, the pressure, velocity and temperature is kept as a constant value, whereas on the other side the velocity and the pressure is reduced. So here, so when these pressure and velocity is reduced, what happens is some cooling effect is obtained. So this process is called as the throttling process. So in throttling process, just the gases expands through the porous plugs. So when this takes place, so here we are getting a cooling effect. So here what happens is the temperature and the pressure is changing. So with the entropy is constant. So this is expressed by an equation by nu. This is called as Joule Thomson coefficient or Joule Thomson effect. So here, so what is the existing difference between the normal cooling and what is the existing in the Joule Thomson coefficient or Joule Thomson effect? So in the existing variable compression refrigeration systems and all, we are using compressors where the efficiency plays a very important role. Here we are calling it as the COP, coefficient of performance. Here always the coefficient of performance is output by input. So the output is always the refrigerating effect and the input is always the work done. So here in these cases the work done is more because of some energy is utilized to do the work, and then we are getting a refrigerating effect. So the energy plays an important role. Here just the expansion of the gases takes place in the throttling process. So this is completely insulated, therefore no heat transfer takes place in this Joule Thomson coefficient, and also no work done takes place. So this is one significance of this Joule Thomson coefficient. And here by varying the pressure, so one side we are keeping the already I have told that the parameters are kept constant on the one side, and the other side the parameters are changed. So when these parameters are reduced, what happens is this cooling effect is obtained. So this effect is called as the Joule Thomson coefficient. So these experiments can be repeated for various sets of pressures, and then this can be drawn in an PV or PD diagrams, and then the slope can be for the various set of drawings. We can conduct this experiment and then we can draw the curves to get a slope. So the slope can be calculated, so which gives the Joule Thomson coefficient. So this cooling effect can be utilized in many real-time applications. So nowadays due to many industrial applications and in domestic purpose, cooling is very important. So this Joule Thomson coefficient or effect can be utilized for our day-to-day lives. Thank you.